In this video, we want to discuss SI derived units. So we know from our previous discussion that there are 7 base SI units that are used in the metric system, and you can see those here. All other units that we use in the metric system are derived from some combination of these 7 base units. These are called derived units. You can see some of these here. These are some of the more common SI derived units that of course are derived from these 7 base units: area, volume, velocity, acceleration, etc., etc. Here we want to just discuss 2 of these that we use very often in chemistry: volume and density. But if you would, pause the video and write all of these down, because we do use several of these and we want to be familiar with them. So let's examine the following derived SI units for volume and density. Let's start with volume. The SI unit for volume is the meter cubed. Obviously, this is derived from the SI unit for length, which is the meter. But just as, or even more common than the meter cubed, we express volume as a centimeter cubed, which is the same as a milliliter. So let's take a minute to discuss this. So if you had a box that was 1 meter cubed, well, that box would have a height, length, and width of 1 meter, and you could see that here. So this would be a certain volume. If you took one box from that was 1 decimeter cubed, that box that's 1 decimeter cubed would be equal to 1 liter. And then if you took 1/10 of that volume, which is a box that would be 1 centimeter by 1 centimeter by 1 centimeter, or 1 centimeter cubed, well, that box would have a volume of 1 milliliter. So of course we use very commonly the unit of volume of a liter, which is the same as a decimeter cubed. And of course we measure volume very commonly in milliliters, which is the same as 1 centimeter cubed. So let's discuss our other SI derived unit, which is the units for density. Density is the ratio of a substance mass to its volume. So density is equal to the mass of a substance divided by that substance's volume. The SI unit for density, well, the SI unit for mass is the kilogram, and the SI unit for volume is the meter cubed. So the derived SI unit for density is the kilogram divided by meters cubed. So even though that's the SI unit, more commonly we express density in units of grams per centimeter cubed, which is the same as a gram per milliliter, because remember, a centimeter cubed is the same as a milliliter. So density is what we call an intensive property. It doesn't depend on the amount of a substance. If you had a large mass of a substance, well, then you would have a large volume. If you had a small mass of that substance, the volume would be small, and so the ratio of mass to volume would be the same. So the density of gold, let's say, is the same whether you have a lot of the gold or a small mass of the gold. It's the same. And of course, different substances have different densities. Here are 2 of the most dense elements, osmium and iridium, and you can see their density expressed in grams per centimeter cubed. So these 2 elements are the most dense, or have the elements with the highest density. So let's look at osmium in a little bit more detail. The density for osmium is 22.59 grams per centimeter cubed. So what that says is that if you had 22.59 grams of osmium, it would have a volume of 1 milliliter. Or vice versa, if you had 1 milliliter of osmium, a cube of osmium that was 1 centimeter by 1 centimeter by 1 centimeter, that 1 centimeter cubed volume of osmium would have a mass of 22.59 grams. So you can see it's very dense. Now we can write this density, 22.59 grams per centimeter cubed, as a fraction, and we do this because it's much easier when we begin to solve problems using density. So we can solve it using dimensional analysis, which we'll discuss more later. So we could say 22.59 grams divided by 1 centimeter cubed. That would be the same as what we have here. Or we could flip it over. 1 centimeter cubed of osmium has a mass of 22.59 grams. We could not say, however, 22.59 centimeters cubed of osmium has a mass of 1 gram. That would be incorrect. So we could not write the density as you see here. These two would be incorrect. So the 22.59 has to stay with the grams, and the 1 centimeter cubed, or the 1 has to stay with the centimeters cubed. So here you can see a table with some other densities of some common substances. And if you look at this closely, maybe pause the video for a second, look at this. You should see that some of the substances that are metals, aluminum, iron, copper, these have much higher densities than substances that are gases like oxygen and hydrogen, or liquids like ethanol or water. That's because metals, the atoms are packed together much more tightly than substances that are gases or liquids. And so the density or the mass per volume is much greater for metals. So let's take a look at a couple of problems involving density. Calculate the mass in grams of a liquid with a density of 3.2 grams per milliliter and a volume of 25 milliliters. Pause the video and see if you can use dimensional analysis to solve this. So we're given our volume of 25 milliliters, so we could put that over 1, and we want to multiply it or use the density to convert it into mass. Now we said we can write that as a conversion factor like you see here. So 3.2 grams of our substance has a volume of 1 milliliter. So our milliliters cancel, and if we multiply that out, we end up with 80 grams. So for this substance, a 25 milliliter volume of this substance has a mass of 80 grams. Let's try one more problem involving density. Find the volume that 35.2 grams of carbon tetrachloride will occupy if it has a density of 1.6 grams per milliliter. So again, pause the video and see if you can set this up using dimensional analysis and solve. So we have our mass, 35.2 grams of our substance, and we're given the density. I want to put the grams on the bottom so they'll cancel, and the 1 milliliter on top. Again, the 1.60 has to stay with the grams. So solving this problem, our grams cancel. We divide 35.2 by 1.6, and we get a volume of 2.20. So if we have 35.2 grams of carbon tetrachloride, it will occupy a volume of 2.20 milliliters. So be sure you're familiar with these derived units. Be sure you can solve problems involving volume and also density.